Section 4. Subtracting polynomials. 17. Consider the effect of a negative sign on the value of an expression. Part A. If f is negative 3, what is negative 1f? Negative 1 times f would be the opposite of f. And if f is negative 3, then we want the opposite of negative 3, and that would be positive 3. Part B. Simplify negative 1 times the expression 3 minus 7 in two different ways. The first way you could do this is to simplify inside the parentheses first. So you could write negative 1 times, well, 3 minus 7 is negative 4, so put negative 4. And now we have negative 1 times negative 4, which is positive 4. The second way you could do this is to treat the negative 1 as a number that is multiplied by 3 and a subtracted 7. So you could distribute the negative 1 to the 3, which makes it a negative 3, the opposite, and then negative 1 to the subtracted 7, which makes it a subtracted negative 7. Negative 3 minus negative 7 is negative 3 plus 7, and negative 3 plus 7 is equal to 4. Part C. If y equals 2x minus 7, then what is the value of negative y? We can see that y is the same as 2x minus 7, so the opposite of y is the opposite of 2x minus 7. And the opposite of 2x minus 7 is negative 2x plus 7. We can also look at that as distributing a negative 1 to 2x, making it negative 2x, and distributing a negative 1 to 7, so it's minus negative 7, or plus 7. So the value of negative y is negative 2x plus 7. 18. What is the opposite of x plus 9? It's not x minus 9. If you need an example, think about what if x is 2. 2 plus 9 is 11. Then what's 2 minus 9? That's negative 7. Well, those are not opposites. If I had negative 2 and then minus 9, that's negative 11. So those are opposites. The opposite of x plus 9 is negative x minus 9. 19. Write each expression such that there are no parentheses. Part A. Negative the quantity x plus 12. We're going to distribute the negative to the x. We can think of that as making x the opposite, so it's now negative x, and then distribute the negative to plus 12, so it becomes a minus 12. The opposite of x plus 12 is negative x minus 12. Part B. The opposite of negative x squared plus 3x minus 2. If you distribute this negative to all of these and make all of them the opposite, their signs will change. Negative x squared becomes positive x squared, which I can just write as x squared. Plus 3x becomes minus 3x. Minus 2 becomes plus 2. Part C. The opposite of x squared plus 2xy minus 4y squared. When I distribute the negative to the first term, x squared becomes negative x squared. When I distribute it to the next term, plus 2xy becomes minus 2xy. And if I distribute it to the last term, minus 4y squared becomes plus 4y squared. In the previous scenario, the negative sign to the left of each expression in parentheses indicates that you multiply by negative 1. The negative 1 is treated like a coefficient, and when a coefficient is negative 1, as in negative 1x, you only need to write the negative sign. Mathematicians like to save time when possible. So instead of a negative 1, you just write a negative sign. You can also think of this negative sign right here and here and here as the opposite of. Number 20. If negative x minus 2, or the opposite of x minus 2, can be written as negative x plus 2, then what is another way to write 3 minus x minus 2? Well, we need to think about how to subtract both x and minus 2. Well, that's like distributing a minus to subtract the x and subtract minus 2. If I bring down the 3, I am subtracting x and subtracting negative 2. Subtracting negative 2 is adding 2. I can bring down the 3 and the minus x. Now I have 3 minus x plus 2. If I can combine like terms, I should. I have a 3 and a plus 2, so that would be 5. And then the minus x cannot be combined with anything else, so I can just write it as minus x. 5 minus x is the most simplified form of 3 minus the quantity x minus 2. 21. Write an expression that is equivalent to x plus 3 minus the quantity x minus y. First, I will distribute this minus through the parentheses to the x and to the minus y. Before I do that, I'll bring down the x and the plus 3. Now I can subtract x and then subtract negative y. Minus a negative y can be written as plus y. And I can bring down the other terms, x plus 3 minus x. If there are terms I can combine, I can do that now. Plus x minus x, those can be combined, but they make 0, so I wouldn't write anything. There's a plus 3, but there's no other constant term, so I can't combine that with anything. And then if I look at the plus y, there are no other terms with y in them, so my final form of this would just be 3. We don't need the plus, it's a positive 3 if I write nothing there, and then plus y. You could also write it with the y first, y plus 3. These are two equivalent expressions, so either one is fine. 22. Subtract the following expressions. Part A, x plus 11 minus x plus 3. This is a binomial in parentheses, and this is a binomial in parentheses. The first parentheses don't need to be there because there's no value being multiplied by that expression in parentheses. However, these second parentheses need to be there because I'm subtracting this entire quantity. So let's distribute this negative sign through the parentheses into this expression so we can remove those parentheses and combine like terms. The first expression, x plus 11, doesn't need the parentheses, so I'll just write that. And then we're going to write minus the quantity x plus 3 as minus x minus positive 3, which is just minus 3. Now I can look at terms that can be combined. X and minus x can be combined, but they create 0, so there's nothing to write there. Plus 11 and minus 3 is 11 minus 3, or 8. And that's your simplified final expression. Part B, 5y squared minus 20 minus 2y squared minus 5. We have a binomial minus a binomial. This binomial doesn't need parentheses around it, so I'll just bring that expression down as 5y squared minus 20. Then I will distribute this minus sign through this set of parentheses. So instead of 2y squared, I can write minus 2y squared. And instead of minus 5, I can write minus a negative 5, or minus a subtracted 5. That's just plus 5. So I can bring down everything else, 5y squared minus 20 minus 2y squared, and write plus 5 instead. Now let's combine like terms. The first term is 5y squared, and there's a minus 2y squared also. 5 minus 2 is 3, so 5y squared minus 2y squared is 3y squared. I have a minus 20, that's a constant, and a plus 5, another constant. Negative 20 plus 5 is minus 15. And I cannot combine those two terms, so our final result is a binomial. Part C, x squared minus the quantity 5x minus 1. Let's distribute this negative sign, or subtraction sign, through these parentheses. First I'll bring down the x squared, and now it's minus 5x, and then minus 1, which is just plus 1. I can bring down the other terms, x squared minus 5x plus 1, and that's my final expression. I cannot combine any of those terms, so my final result is a trinomial. 23. Subtract the following expressions. State whether your final answer is a monomial, binomial, trinomial, or none of these. Part A, 2x minus 5y minus 2x plus 5y. A binomial minus a binomial. We don't need these first parentheses, so I can just bring down the expression 2x minus 5y, and then I can distribute this minus sign to both of these terms. Minus 2x, and then minus a positive 5y would be minus 5y. Now I can look for terms that can be combined. 2x minus 2x, those cancel each other out, they make 0. And then I have negative 5y and minus 5y again, that's minus 10y. So my final result is one term, and it is a monomial. Part B, 3x squared minus the quantity 6x squared minus y squared. I can bring down the 3x squared and then distribute this minus to both of these terms. That becomes minus 6x squared, and then minus a negative or minus y squared. Minus a minus, the opposite of minus is plus, so it's plus y squared. I'll bring down the other terms, 3x squared minus 6x squared, and then look for terms that I can combine. 3x squared can be combined with minus 6x squared. That would be negative 3x squared. And then plus y squared cannot be combined with any other terms, so I will bring that down. And then I can look at my two terms. They can't be combined, so that is a binomial. Part C, x squared minus 5x plus 4 minus 3x squared minus 5x minus 1, a trinomial minus a trinomial. I don't need the first set of parentheses, so I can just bring down that trinomial, x squared minus 5x plus 4, and then I can distribute this minus to subtract all three of these terms. It becomes minus 3x squared, and then minus 5x would be plus 5x, and then minus 1 would be plus 1. Let's look for like terms. X squared minus 3x squared. X squared minus 3x squared is negative 2x squared. Minus 5x plus 5x. Those combine to make 0. So there is no term with x in my final expression. Plus 4 plus 1. That would be plus 5. These two terms can't be combined, so the final expression is a binomial. 24. Subtract the following expressions. State whether your final answer is a monomial, binomial, trinomial, or none of these. A. There's a trinomial minus a 4-term polynomial. This trinomial doesn't need parentheses because there's no number being multiplied by that trinomial, so I'll just bring it down. X cubed minus 2x minus 7. Now I can distribute this minus through all 4 of these terms. The 4x cubed becomes minus 4x cubed. The minus 8x squared becomes plus 8x squared. Plus 4x becomes minus 4x. Minus 2 plus 2. Starting with this first term, x cubed, let's find other x cubed terms. There's one of them. So I have x cubed minus 4x cubed. That is negative 3x cubed. The next highest exponent is this term 8x squared, 8x to the second power. And there's only one term like that, so I will just bring it down, plus 8x squared. Now we can look for terms with x. There's a minus 2x and a minus 4x. Minus 2x minus 4x is minus 6x. And lastly, the constants, minus 7 and plus 2. Negative 7 plus 2 is negative 5, so I can write minus 5. There are no other terms that I can combine, so I have a 4-term expression, which is none of these, or you could just say it is a polynomial, but we'll just say it's none of these for now. Part B, we have a trinomial minus a trinomial. 2x squared plus 3xy minus 4y squared has no value distributing into the parentheses, so I can just bring down that expression as it is. 2x squared plus 3xy minus 4y squared. This minus sign can be distributed to each of these 3 terms. It becomes minus 3x squared plus 4xy is now minus 4xy, and then minus 6y squared becomes plus 6y squared. Let's look at terms that can be combined. 2x squared minus 3x squared. 2 minus 3 is negative 1, so we can write negative 1x squared. I will just write negative x squared. The next term we can combine is xy. There's another xy term, 3xy minus 4xy. 3 minus 4 is negative 1, so negative 1 or just negative xy. Minus 4y squared can combine with plus 6y squared. Negative 4 plus 6 is 2, so that's positive 2y squared. I can't combine any of these terms, so we can just identify what type of polynomial this is. There are 3 terms, so it is a trinomial. 25. Subtract the following expressions. Negative 2.5x squared plus 1.4x minus 3.3 minus negative 0.5x squared minus 0.7x plus 1.2. This first trinomial doesn't need parentheses around it because there's no number being distributed into those parentheses. So I will start by bringing that down. Negative 2.5x squared plus 1.4x minus 3.3. The second trinomial, we can distribute the negative or the subtraction symbol through the parentheses to change the sign of each expression inside the parentheses. Minus 0.5x squared becomes plus 0.5x squared. Minus 0.7x becomes plus 0.7x. Plus 1.2 is now minus 1.2. Let's look for like terms. Negative 2.5x squared plus 0.5x squared. That's negative 2x squared. Next, plus 1.4x plus 0.7x. 1.4 plus 0.7 is 2.1 plus 2.1x. Minus 3.3 minus 1.2, that is minus 4.5. And there's your final expression. It is a trinomial. 26. Determine the area of the shaded region. There is a rectangle and then another shape inside it. X and X mean these are the same, so this is a square. You have a square inside a rectangle. The shaded region is what you get when you take the rectangle and you remove this square or subtract the square. So we are going to take a rectangle's area and subtract the area of a square. The area of the rectangle is 4 times 6. The area of the square is x times x. 4 times 6 is 24. X times x is x squared. So the area of the shaded region is 24 minus x squared. 27. The first expression, 2 plus 4x, doesn't need to be in parentheses. And the second expression is being subtracted, so let's distribute the minus to make it minus 3x squared, and then distribute the minus to the minus 7 to make it plus 7. The only terms that can be combined are the constant terms, the 2 and the 7, and they make 9. Now I'm going to write this in an order that puts the term with the highest exponent first, so that's minus 3x squared, and then the next highest exponent next, which is plus 4x, and then the term without an x in it, the constant term, we will put last. 2 plus 7 is 9, so plus 9. And there's the final result. It is a trinomial. 28. Simplify each expression by applying the distributive property. Part A, 5 times the quantity x plus 6. 5 times x is 5x. 5 times 6 is 30, so that's plus 30. Part B, negative 10 times the quantity 3x minus 7. Negative 10 times 3x is negative 30x. And then we have negative 10 times a minus 7. It will be the opposite of minus, so plus, and then 10 times 7 is 70. You can also think of it as a minus 7 times negative 10, which is plus 70.